All right, so 2003, Form B, free response, number 4, so therefore no calculator. Instead of going through and doing the scoring immediately, I will work the problem and let's see if the teacher can get 9 for 9. All right, theoretically. All right, so no calculator. A particle moves along the x-axis with a velocity at time t greater than or equal to 0 given by velocity t equals -1 plus e to the 1 minus t. Find the acceleration of the particle at time 3. Well, first of all, we know that the acceleration is the derivative of velocity. So I need to find d prime of t. So I would write this, and I would take the derivative, which is 0 for -1. Rid of e to the 1 minus t is e to the 1 minus t times derivative of the top t times
negative
1. So I will put the -1 here. All right? And I would rewrite this so it's clear. And I'm trying to make this scoreable. All right, so this would be when I write my page. Find the acceleration. So I would simply plug in a sub 3 equals negative e to the 1 minus 3. So I would get a sub 3 equals negative e to the -2. And I most likely would write that as a sub 3 equals -1 over e squared. And I would say that is my answer for B. I'm going to group it. I am done. We'll save that for scoring.
Would they accept?
We'll see what they accept in a second. Okay? We're going at this. So 60 seconds, we got that done. Is the speed of the particle increasing at time 3? Give a reason. Okay, speed is the key here. Remember, speed, think of a car. If you're in drive, going forward, and you push the accelerator, your speed increases. Likewise, if you're in reverse and you push the accelerator, your speed is increasing. So we have to know two things. We have to know the acceleration and the velocity. So that V of 3, do you guys agree? This is letter V. At V of 3, do you agree you have -1 plus e to the 1 minus 3? And here's all I care about. I can tell that I get -1 plus, and I probably would not write all this on mine, but I get this. Do you guys agree this is about 1/9 e squared? Right here, this is about 1/9. So, yes. So you guys agree this is less than 0? So do you guys agree that this is going backwards? The velocity at 3 is going backwards. Now, if its acceleration is positive, it is slowing down, right? Because it was going backwards and the acceleration is going forward. If the acceleration is negative, but I know looking at my acceleration from letter A, from A of 3 is less than 0. Thus, speed is increasing because V of 3 is less than 0 and A of 3 is less than 0. This is the way I would write it. We'll see if I get a full point. We'll see if I did this right, but that makes sense to me. I'm feeling good about it. I grouped this. All right, and I shrink it down. We're going to come back and score these, all right? So now, letter C. Find all values of t at which the particle changes direction. Justify your answer. Okay. A particle changes direction when the velocity goes from negative to positive or positive to negative. So what I'm going to do, and I know, I'm going to say I want to find C. I want to know when V of t equals 0. You guys agree? Does that make sense to everybody? So if I do that, I have 0 equals -1 plus e to the 1 minus t. So I get 1 equals e to the 1 minus t. I've done this in a different color. Letter C, that's all right. All right. If I look at this, I'm going to split. I'm going to have to do the natural log. You guys agree? ln of 1 equals ln of e to the 1 minus t. And this might be where you guys struggle. This is what we have to remember from chapter 7. So 1 minus t is going to come down. You guys agree? ln1 and ln e. Now, see, this is where it pays to really learn this. ln e is 1. Yep. ln1 is 0. So within a matter of seconds, I can go 0 equals 1 times this is just 1 minus t. So t is 1. Move t to the other side. So t is 1 second. So I know at 1 second the velocity is 0. Now, do you guys agree that I know from B, little letter B, that the velocity at 3 was less than 0? You guys agree with that? We knew that. Do you guys all agree?
Yes.
And we know the velocity at 1 is 0. I'm going to put velocity at, say, 0 time. All right? If I plug in 0 here, I get negative 1 plus 1 over e. If I plug in, well, I'm not going to use 0. 0 is a bad choice. I'm thinking I was going to use 0. I'm going to use half. If I plug in half into the original equation, I'm going to get negative 1. I got to look at the original formula without rotating up the screen. Negative 1 plus e to the 1 minus half. You guys agree? Which is e to the half. So I get negative 1 plus e to the half power. All right. Do we agree that the square root of e is greater than 1? All right. If the square root of e is greater than 1, we know b to the half is greater than 0. All right. So, on letter C, find all values of t at which the particle changes direction. Justify your answer. All right. And I'm going to have to consider v of 0 next, but I'm going to say it changes direction at 1. All right. I can justify that particle changes direction at time equals 1 because velocity v sub t goes from positive.
We just say because first derivative rule?
No, we didn't use the derivative. We didn't use the derivative, did we? Huh? How would you? Okay, would you do it? Would you do it using acceleration then? Because we're talking about the velocity. Okay. I think again.
Because if you took derivative of that, you wouldn't have velocity.
Now, the only other thing, I'm going to take 1 second, just cheat and look at the answer. I shouldn't do that, I said I wouldn't. The other thing I would consider real fast here on a piece of scratch paper is I think I'm done, but I would plug in 0 here. If I plug in 0 up in the time on a piece of scratch paper, I would make sure of this. You guys agree I get like this? Oh, so it's obviously it's positive. So I'm okay. All right, I'm okay, and that's one of my endpoints. So it's positive. All right, good. So v of 0 would have been an okay choice. All right, I'm done with B. Or B. I am done with C. Oh, I didn't get that. All right. Alright, so there's C. Now we got to go to D. Find the total distance of the particle traveled over the time interval 0 to 3. Alright. We know that this is not displacement, so you can't do just the integral. But the notation, remember, is this. I think if I do the absolute value of this, that's going to be the total distance. Alright? But we now know from letter C, alright, that there's a change in direction at time 1. If we're going to do this longhand, and we have to, right? And let's recall, I'm going to write this so that we don't have to go back to the top of the board as we go down. We know this function. Do you guys agree? All right. I'm going to have to break this integral apart at the 0 velocity.
1 to 3.
And because we're going to do it longhand. You calculate, yep. 1 to 3, 0 to 1, 1 to 3, or 1 to 3, and 0 to 1. Doesn't matter what order you have. But I have to break this apart because think about it. Initially, the velocity is positive. So you're going to get a positive answer to distance or displacement. From 1 to 3, the integral is going to be negative if we don't do the absolute value. Your calculator would do this, but this is a non-calculator problem. So I would rewrite this as 0 to 1 v of t dt plus 1 to 3 v of t dt. Because it's longhand. I agree on a calculator test this would be easy. All right, so let's do some math. Oh, what an ugly integral. I only have to do one of these well. So on a piece of scratch paper, I would probably do this integral right here. I need to integrate -1 plus 1 minus t dt, right? So if I do that integral, and that's an absolute value, all right, you guys are going to get negative t. And again, you might have to do u substitution, but Mr. Anderson doesn't need that practice. I'm pretty sure that's it. And I'll check it by doing what? Take the derivative. Derivative of negative t is -1. Derivative of e to the 1 minus t is e to the 1 minus t times -1. Two negatives make a positive. And this is the sign you guys usually miss right here. All right? All right. So that said, I think this is my integral. Maybe I would just do this on my test paper. I don't know. I might have written it on the side. But at this point, I am going to do this. And this is the absolute value. And I would do the absolute value. And I know this is the same antiderivative. You guys agree? I know when I get an answer here, this is going to be positive, this first one, because I was going forward, and this is going to be inside, it's going to be negative. You guys agree? All right, let's see if I'm right. I'm going to do the integral. If I plug in the numbers, I get -1 minus e to the 1 minus 1 minus -0 minus e to the 1 minus 0. That's the first one. And I would actually write that on the AP, trying to keep it fitting, plus the absolute value of, oh, yuck, -3 minus e to the 1 minus 3 minus.
You can write out, either severe.
Well, I would actually plug it in first and simplify. Yeah, I would write this. I'd write what I wrote in blue. Because, guys, I don't want to make a math mistake. Maybe I would do it on a side piece of scratch paper, but I do not want to screw up at this point. And I'm just as likely as you guys to make a math mistake. All right? I'm not infallible. All right, I think I get -1 minus e to the 0 is 1. Do you guys agree? Minus, that 0 goes away. I get negative e to the 1, or negative e, plus, and over here I think I got -3 minus e to the minus 2 minus negative e. All right, here I go. I get -2 plus e plus, this is -2, right? Minus 2. So over here, -3 plus 2 is -1 minus e to the -2. All right, and just what I said, guys, this is positive, right? Think about it. -2 plus 2.7. So this is e minus 2. That's the first one, when I do the absolute value, right? Over here, do you guys agree these two both go the same direction? So this is going to become, when you take the absolute value, you got to think this through your head. You guys agree with that? This would become -1 minus 1/9. So -1 and 1/9, so it becomes +1 and 1/9 for an estimate. Okay. I'm estimating e to the -2 as 1/9. Add these up. I think the answer is e plus 1 over e squared minus 1 is the distance. And was there units on this?
I don't think so.
Nope, no units. So I would argue that is the total distance traveled over the time period. And that problem is just long. Holy cow. I got to change my view. And I'm going to group that as one big ugly. Should we score backwards today? Let's score this first and work our way. So there's D. All right, and I'm just going to read this, and it'll live in forever. We'll see if I did this correctly or incorrectly at this point. All right. So I grabbed the answer sheets. So let's see where I'm at time. 15 minutes. So on letter D, it's worth 4 points. Almost all the values of problems in letter D. All right. The first point in the method I did, and there's a secondary method we'll talk about, first point is the limits, 0 to 3, and that you had the integrate v of t dt. If you had that, you got 2 points actually. That you had this antiderivative as a point right here. So there's your third point. And finally, the evaluation to get this answer right here. All right? You would need, well, no, you need the 3 things I underlined. That's, yeah, they show 1, 2, 3, 4, 5 lines. I showed 1, 2, 3, 4, 5, 6, 7, 8, 9 lines. They go from, they don't show, the only blue they show is the last step. They don't show anything in this box right here. But I don't know how you would do it without doing those steps. So why wouldn't you do it? All right, so Mr. Anderson, yay, got 4 points out of 4. All right, there is another way to do this problem. All right, and the other way that they did this, all right, if I get rid of that, is they said, hey, you can take the derivative, antiderivative of v of t. You guys agree? And if you get that position formula, yeah, and think about it, they could do the distance from those points. And what they did is they took the antiderivative and they figured out the position at x sub 0, x sub 1, and x sub 3, right? So they took the antiderivative. And even though you don't know the plus c, it doesn't matter, does it, when you do the antiderivative? Because if you get these positions at these times, can't you just do the difference? So when they found that x sub t was equal to the antiderivative, and I don't particularly like this method because my argument is we need a plus c here. We didn't know the position at time 0. They assumed 0 because they didn't put plus c. I think it's a bad assumption. But the point is, it doesn't matter. If we had the plus c, I would have wrote plus c, not on the AP. I would have got negative e plus c here. I would have gotten negative 2 plus c here. And I would have got negative e, negative 2, minus 3 plus c. But when you start subtracting these, because this distance is x3 minus x1, the c's go away. This distance is x1 minus x0, the c's go away. And when you add those up, you get the same answer I had. All right, so that method would work also. All right, let's move to C. All right, letter C on this problem is worth 2 points. Solve for v of t and get t equal 1 is 1 point. So solve for v of t and get 1. You have to have this part right here. V of t for 0, so really you need to have this line and for this line. And again, without a calculator, I don't know how you guys would get between those steps without what I did. Justifies change in direction at 1. Okay, and again, they did it the same way I did. They said v of t was greater than 0 for t less than 1, and v of t is less than 0 for t greater than 1. The same thing I said here. That justification is worth a point. All right, so I am now 2 for 2 on this one, 6 for 6. You would hope I would get this right? But again, I come there are AP problems even I sometimes make mental mistakes on. All right, so for letter B, the next one, you have to have an answer with a reason to get 1 point. So the answer here is speed is increasing since v of 3 is less than 0 and a of 3 is less than 0. It's exact. My sentence was exactly what their sentence was. It shows you how long I've been teaching AP Calc.
With sign everything.
And they spelled out because instead of me using the symbol, but that's it. Let's do letter A. So think about it. I am 7 for 7 right now. That means A has to be worth 2 points, right? Everyone's worth 9. So this is 2 points. 1 point is for V prime. So negative e to the 1 minus t right here is worth a point, this derivative. And then the answer A of 3, which is negative. They had this, actually. That's what they show as the answer. So that answer. They didn't take this step. So I already got a point for both. And that would make 9 for 9. 10 minutes.